ඉන්නවා නම් පොඩ්ඩක් කන්ෆර්ම් කරන්න. එයාලටත් මොන හරි තොරතුරක් ආරංචි වුණොත් අපිට පොඩ්ඩක් කියන්න. ඒත් එක්කම මේ මෙතන කැමති කෙනෙක් ඉන්නවා නම් අපි මේ ඕගනයිස් කරන්නේ රේඩියෝ සොසයිටි එකෙන්. එතකොට අපි මේ විජේ ෆෝරෙසම් නිට්ට ජුලියට් එයාගේ කාලය ශ්‍රමය මහන්සි ඔක්කොම වැය කරලා මේ ඔයගොල්ලෝ වෙනුවෙන් මේ ලෙසන්ස් ටික කරන්න ඩිස්කස් කරන්න එකතු වෙලා ඉන්නේ අවුරුදු ගාණක් තිස්සේ. සෝ ඒකින්ද පුළුවන් නම් මම ආරාධනා කරනවා මෙතන දැනට රේඩියෝ සොසයිටි මෙම්බර්ස්ලා නොවන අය ඉන්නවා නම් මෙම්බර්ෂිප් එකක් ගන්න කියලා. ඒකට අපි ඔය Facebook page එක වෙබ්සයිට් එක වගේ ගිහින් බලපුවාම ඔයාලට ඇප්ලිකේෂන්ස් එහෙමත් හොයාගන්න පුළුවන්. ඒ ප්‍රොසීජර් එක දැනගන්නත් පුළුවන්. ඒක නිකන් මතක් කිරීමක් පමණයි. නමුත් ඕන කෙනෙක්ට මේකට ජොයින් වෙන්න පුළුවන්. හරි, එහෙමනම් මම විජේට බාර දෙන්නම් සෙෂන් එක කන්ටිනියු කරන්න. විජේ ගන්න පුළුවන් නේද විජේට? ඒත් එක්කම මේ අපේ නෙට් එක අහන්නේ නැති කවුරු හරි ඉන්නවා නම් අහන්න පහසු ගන්න නැති කෙනෙක් ඉන්නවා නම් ඒකත් ඉක්මනටම හදාගත්තොත් හොඳයි කියලා හිතනවා. යටි අන්තට පිදුරු තලාගල ෆ්‍රීකවන්සිස් වල නෙට් එක හැමදාම 9 pm වලට යනවා. විජේ සතිය ගොඩක් දවස් වලට විජේ තමයි නෙට් කන්ට්‍රෝලර්. ඔයාලට පුළුවන් නම් ඒකත් අහන්න, ඒකත් ගොඩක් වටිනවා. over to you විජේ.
ඕකේ සරන්. ඔව්. එහෙමනම් මම පටන් ගන්න අලුතෙන් ඇවිල්ලා ඉන්න කාටවත් අවශ්‍ය නම් මේ lessons මම දාලා තියෙනවා දෙවිදියකට. මගේ වෙබ්සයිට් එකේ දාලා තියෙනවා මෙතන තියෙන මේ ඇඩ්‍රස් එක www.qsl.net /4SM4SM VJ. ඒකේ තියෙනවා හැම් රේඩියෝ කෝස් කියලා. අන්න ඒකට ගියා නම් ඒකේ ලිස්ට් එකක් තියෙනවා. lessons කියලා තියෙනවා. මම හිතන්නේ උඩින් ඒක ඉංග්‍රීසි වලින් තියෙන එක. ඉංග්‍රීසි මීඩියම් එකෙන් lessons වෙනමම chapters 8ක් හැටියට තියෙනවා. chapter 1 2 3 ඒ විදිහට 8ට එනකම් තියෙනවා. ඊළඟට සිංහලෙන් තියෙනවා ඊට පල්ලෙහායින් ඇත්තේ මට මතක හැටියට ඒකේ lessons in සිංහල කියලා මම හිතන්නේ නැත්තේ. ඔව් ඒකේ අර chapters 8ම තියෙනවා. ඒ වගේම ඊට පල්ලෙහායින් තියෙනවා RAE course කියලා. ඒක බලන්න ඒකේ එක ෆයිල් එකක් PDF ෆයිල් එකක් හැටියට තියෙනවා. අර කලින් ඒවා ටික ඔක්කොම එකට එකතු කරලා ඒ වගේම ඒක අප්ඩේට් කරලා තියෙනවා මම නිතර. අර ඉංග්‍රීසි ඒවා ටික නම් මට වැඩි අප්ඩේට් කරන්න හම්බ වුණේ නැහැ. ඉතින් ඒ ඇරෙන්න තව මේ YouTube වල දාලා තියෙනවා. YouTube වල පොඩ්ඩක් සර්ච් කරනවා නම් මගේ නම දාලා සර්ච් කරන්න ජයශ්‍රී විජේරත්න කියලා තියෙනවා. ජයශ්‍රී විජේරත්න කියලා සර්ච් කළා නම් ගන්න පුළුවන්. ඒ ටික YouTube වල තියෙනවා. එහෙම බැරි කෙනෙක් ඉන්නවා නම් මම ලින්ක්ස් ටික වෙනම එවන්නම්. WhatsApp වල මෙසේජ් එකක් දැම්මනම් විදිහට පුළුවන්. එහෙමනම් දැන් අලුතෙන්ම ඉන්නවා නම් වැඩිපුර අවබෝධයක් නැති අය ඔය lessons ටික follow කළා නම් මේ M radio ගැන මේ පුළුවන් දැනගන්න විස්තර. ඊළඟට past papers තියෙනවා. ඒකම M radio course කියන එකේම past papers දාලා තියෙනවා. මේ past papers තමයි දැන් මේ ඩිස්කස් කරන්න යන්නේ. මම හිතන්නේ අර අනිත් theory part ඔක්කොම පුළුවන්නේ YouTube වලින් නැත්නම් මේ අර කලින් කිව්ව lessons වලින් බලා ගන්න පුළුවන්. ඒක නිසා past papers විතරක් දැන් ඩිස්කස් කරමු. අනිත් ඒ exam එක තියෙන dates මම දාලා තියෙනවා මේ මාසේ 13 වෙනිදා තියෙනවා gender class, 27 වෙනිදා තියෙනවා novice class, 28 වෙනිදා advanced class තියෙනවා. ඉතින් ඒකත් මතක තියාගන්න. එතකොට ඔය 13 වෙනකම් ඒ කියන්නේ 12 වෙනිදා වෙනකම් මම බලාපොරොත්තු වෙනවා මේ විදිහට past papers සාකච්ඡා කරන්න. එහෙමනම් දැන් අද අද මොකක්ද මුකුත් විශේෂයෙන් තෝරගෙන එහෙම නෑ මම මුකුත් විශේෂයෙන් මොනවා හරි පාස් පේපර්ස් තියෙනවා නම් පොඩ්ඩක් කියන්න බලන්න. ඔය මගේ වෙබ්සයිට් එකේ තියෙනවා ඒ පාස් පේපර්ස් දාලා ඒක නිසා ඒකෙන් ඩවුන්ලෝඩ් කරගන්න පුළුවන්. තරංග මුකුත් ලෑස්ති වෙලා එහෙම ඉන්නවද? මං කලින් කරපු ඒවා පොඩ්ඩක් බලලා ඒකක්ම ගන්නද?
තරංග
කමක් නෑ තරංග නැත්නම් අනිත් කවුරු හරි අවශ්‍ය කෙනෙක් ඉන්නවා නම් පොඩ්ඩක් උත්තර දෙන්න. මම මේ කලින් ඩිස්කස් කරපු ඒවාම අරගන්නම් දැන් බලන්න.
අපි එහෙම කරමු මිස් විජේ.
ඔව්
මොකද
සර් වරුණ මම අන්තිමට කෙරුවේද 2018 ජෙනරල් එක කෙරුවේ මේ ජෙනරල් මේ ඒක කෙරුවේ 2018 අන්තිම කරපු එක කරමුද අන්තිම ඉඳන් එහා පැත්තට
කමන්නේ 2018
අන්තිමට කෙරුවේ 2018
ඔව්
18 කළා නේද?
ඔව්
කරලා තියෙනවා නේද?
ඔව්
මම මේ පේපර් එක අරගන්නම් එහෙනම් දැනට.
තුන්වෙනි මාසේ 19 වෙනිදා තමයි අන්තිමට කෙරුවේ.
19 වෙනිදා මම ලියාගෙන තියෙන 17 වෙනිදා කියලා. එහෙනම් 19 වෙනිදා 19ක් කරන්න නැති මං හිතන්නේ.
ඔව් 2018 කරමු සර් අන්තිමට කරුවේ ඒකේ ඉඳන් අනිත් එහාට යන්න මන් දන්නේ මේක හොඳයි දන්න සේම හොඳයිද
ඔව් කමන්නේ හොඳයි.
ඔව් කමන්නේ ඒකනේ අපි මේ ළඟම තියෙන එකකට තිබ්බ එක්සෑම් එක නේද? ඒතර ඒකත් එක්ක කෙනෙක් මම හිතන විදියට හොඳ වෙයි කියලා හිතනවා. කට්ටිය කැමති වෙයි කියලා හිතනවා නේ. ඉතින් එහෙම අපි බලමු එහෙම නේද?
අනිත් එකද මේ නොයිස් ක්ලාස් කරන අය ඉන්නවා. ඒ හින්දා මං හිතන්නේ ප්‍රශ්නයක් එන්න මේ ඒ අයටත් එකක් වැඩියෙන් රිෆ්‍රෙෂ් වෙයි ඔක.
ඔව් ජෙනරල් එක අපි මෙතන කරලා ඊට පස්සේ අපි ඊළඟ ඒත් එක්කම වොයිස් එකටත් යන්න බලාගෙන වගේ එහෙම දාගමු නේද? මොකද ජෙනරල් ක්ලාස් ටිකක් මං හිතන්නේ ගියා නේද අපි වැඩිපුර.
ඔව්.
කෙරුණා කියලා මම හිතනවා.
ජෙනරල් and noise දෙකම මේ අපි මාරු වගේ කරමු. ඉදිරියට ඇඩ්වාන්ස් ක්ලාස් ඒවත් කරමු. ඇඩ්වාන්ස් ඇප්ලයි කරපුවා ඉන්නවද දන්නේ නැහැ. එහෙම නැති වුණත් ප්‍රශ්නයක් වෙන්නේ නැහැ. මොකද ওই තුනේ එච්චර ලොකු වෙනසක් නැහැ. ඒ නිසා ඒ විදිහට කරමු අපි. එහෙනම් 2018 පේපර් එක මම දැන් දාන්නම් බලන්න.
විජේ ඒ අතරේ අපි පොඩ්ඩක් කට්ටිය වන්දර ගමු තලුතෙන් ආපු අය. පරණ අය නම් දන්නවත්.
ඔව් පොඩ්ඩක් ඉන්න වගේ මේ වින්ඩෝ එක ගියා ඒක මම බලන්නේ.
තරංග ඉන්නවා තරංග.
කසුන් ඉන්න. ඔව්. කොහමද මෙසේජ් එක කියවන්නේද බලන්න බැලුණා ඒක.
ඔව් මේ ඒක මේ ඔඩියෝ මැසේජ් එකක් මට දෙන්න එක මේ ප්ලේ වෙලා නැහැ හරි මොකක් හරි ඔඩියෝ මැසේජ් මේ මම මේක ඒක දැම්මේ මැසේජ් එක ඇවිල්ලා මේ අපේ මෙම්බර්ෂිප් එක කොහොමද ඒක ඉයර් ඔන් ඉයර් මේ අප්ඩේට් කරන්න ඕනද රිනියු කරන්න ඕනද කොහොමද ඒක ගැන පොඩ්ඩක් ඒක ගන්න කොහොමද කියන එකක් දැන් අනිත් කට්ටියත් මෙතන ඉන්න හින්දා පොඩ්ඩක් කියන්න පුළුවන්.
Okay right. So then අපි RSSL ගේ membership categories කීපයක් තියෙනවා. Student memberships, associate membership, corporate ඊට පස්සේ තව category වගේක් තියෙනවා. මම අදාළ වෙන ඒවා ටික විතරක් කියන්නම්. මෙතන ඉන්නවා නම් මොකක් හරි educational institute එක, university එකක්, college මේ ඉස්කෝලයක් නැත්නම් technical college එකක් ඒ වගේ student කෙනෙක් දැනට ඉන්නවා නම් එයාට apply කරන්න පුළුවන් RSSL එකේ student membership එකට. ඒත් එක්කම දැනට ස්ටුඩන්ට් කෙනෙක් නොවන සහ දැනට licensed ham operator amateur radio operator කෙනෙක් නොවන කෙනෙක් ඉන්නවනම් එයාට පුළුවන් associate membership එකට apply කරන්න. ඊට අමතරව licensed operator කෙනෙක් දැන් මෙතන මම හිතන්නේ තවම නැහැ. ඒකට licensed operator කෙනෙක් ඉන්නවනම් එයා corporate member කෙනෙක් විදිහට RSSL එකට බැඳෙන්න පුළුවන්. එතනදී ඊට පස්සේ student members ලට enrollment fee එකක් නැහැ. කෝපරේට් සහ ඇසෝසියේට් මෙම්බර්ස්ලට මෙතන මං හිතන්නේ ගොඩක් අයත් වෙන්නේ ඇසෝසියේට් මෙම්බර්ස්ලා ඇසෝසියේට් මෙම්බර්ස්ලට එන්රෝල්මන්ට් ෆී එක පාර වන් ටයිම් පේමන්ට් එකක් තියෙන්නේ 1000 rupees ඊට පස්සේ ඇසෝසියේට් මෙම්බර්ෂිප් එකේ ඇනුවල් ෆී එක 600 rupees right එතකොට ඒක ඇනුවලි පේ කරන්න තමයි තියෙන්නේ 600 rupees කෙනෙක්ට කැමති නම් අවුරුදු කීපයකට in advance pay කරන්නත් පුළුවන් 600 ඒවා මේ අදාළ අවුරුදු ගානට ඇප්ලිකේෂන් එක අපේ RSSL වෙබ්සයිට් එකේ ඩවුන්ලෝඩ් කරන්න තියෙනව නේද නයින තාමත් අයින් කරේ නෑනේ
මොකක්ද ගන්න
ඇප්ලිකේෂන් RSSL ඇප්ලිකේෂන් එක අයින් නෑ තියෙනවා තාමත් තියෙනවා right ඔව් ඇප්ලිකේෂන් එක තියෙනවා ඩවුන්ලෝඩ් කරගන්න සර්විසස් වල ඇප්ලිකේෂන්ස් කියන ටැබ් එකේ මෙනු එකේ ඊට පස්සේ ඒක ෆිල් කරලා info@rssl.lk එකට මේ ෆෝවර්ඩ් කරන්නකො මම ඇඩ්‍රස් එක දාන්නම්
මේ අපි දැන් පොඩ්ඩක්
අයින් කරනවද
ඔව් ඊට වගේ පොඩ්ඩක් නවත්තන්න මම ඉන්නේ මට අද කරන්න බැරි වුණා ඒක
හරි මම ඇප්ලිකේෂන් එක මේ WhatsApp එකේ WhatsApp group එකේ දාන්නම් ඊට පස්සේ ඒකට payment online transfer එකක් හරි කරලා අපිට ලැබෙන්න සැලැස්සුවොත් receipt එක අපිට ඒක බලලා approve කරන්න පුළුවන් council meeting එකකදී. ඕක තමයි සාමාන්‍ය procedure එක. එතකොට members only benefits තව ඉතින් තියෙනවා society එකේ මම ඒවා මෙතන කියන්න දෙන්නේ නැහැ. එතකොට ඒ වගේ වෙලාවකදී membership එක තියෙන එක වටිනවා අපිට. දැන් මේ class එක open කරාට. අසොන් එක ප්‍රමාණවත් නේද?
ඔව් ඇති තමයි ඇති හොඳට ප්‍රමාණවත් දවුලක් නෑ
එමනම් මම මේ පේපර් එක දාන්නම් මේ මට පොඩ්ඩක් මතක නෑ ස්ක්‍රීන් එකේ දැන් තියෙනවා තියෙන එක දාන්නේ කොහොමද තරංග පොඩ්ඩක් කියන්න මට
විශේෂ ඔකේ තියෙන අර present now කියලා option එකක් buttons වලින් ගත්තොත් 1 2 3 4 5 වෙනි එක
හරි arrow එකක් තියෙන උඩට
අන්න හරි ඒක
your entire screen කියන එක ගන්න ඕනේ නේද
එහෙම නැත්නම් විජේ ඕපන් කරන් ඉන්නේ මොකද්ද මේ Acrobat Reader Adobe PDF එකක්ද
ඔව් PDF එකක් ඔව්
එහෙනම් ඒ window එක විතරක් share කරත් ඇති අර window එක select කරන්න තියෙන්නේ share now click කරාම එතන තියෙන window කියලා
ඔව්
ඒකෙන් ඔය PDF එක තියෙන window එක drop down menu එකක් ඇති විජේ select කරන්න
පොඩ්ඩක් කතා කරන්නද
කියන්න නෑ
නෑ මේ අර අපේ කොරියන් ෆ්‍රෙන්ඩ් දාලා තියෙන එයාට පොඩ්ඩක් තේරෙන්නේ නැහැ කියලා ඉංග්‍රීසියෙන් කිව්වොත් මොකද
okay
ආයෙත් ඉන්නවද
is Kim here Kim are you there
මම හිතන්නේ ඉන්නවා WhatsApp group එකේ තමයි දාලා දෙන්නේ
Kim are you here
Yes, I'm here.
oh, okay sorry we didn't realize that you are here
Okay.
Okay Kim so I think we are going to discuss 2017 past paper for this amateur radio exam
Right.
okay so the exam paper is in English our teacher our resource person Vijay whom you met the other day will explain the or rather discuss the question papers if you have any problem just raise your hand and we will be happy to answer
Oh, okay. All right.
Taranka, can you see the
yeah Vijay now I can see if you can zoom in a little bit it will be clearer but yeah I think for me it's clear enough now
පේපර් එක තියෙන ලින්ක් එක පොඩ්ඩක් දාන්න පුළුවන්ද මේ WhatsApp group එකට
paper එක
2017-18 මම දාන්නම්
මගේ වෙබ්සයිට් එකෙත් අර මේ මොකද්ද මේ
විජේ මම දාන්න හරි විජේ කරන් යන්නකො මම දාන්න
ඔව් මේකේ මම හිතන්නේ මම දැන් මේ පේපර් එකේ ටිකක් තියෙන පොඩි නොපැහැදිලි තැන් මම ටයිප් කරලා දැම්මා ඒක වෙනම මගේ සයිට් එකේ
විජේ මට පොඩ්ඩක් කියන්න මේක ජෙනරල්ද ඇඩ්වාන්ස් එකද කරන්න යන්නේ
ඇඩ්වාන්ස්
Noise
නේද කරමුනේ නෑ ඇඩ්වාන්ස් එක මේ අපි ජෙනරල් එක කරමු
2017-18 general. Hari.
general or we can use noise and general both.
So anyway, you can download all the papers from this link qsl.net/4s7 Victor Juliet 4s7 VJ.
Link is here. Make a පේනවනේ කරන්න. Screen එක පේනවද දැන්?
Yes, VJ. Yeah. 2017-18 novice class. Yeah, can see that.
Then shall I start from noise class?
Okay, Vijay. Now the first exam is also novice class. No, 13th.
No, first exam general class.
General.
Anyway,
General.
general and noise, I think both there is no big difference. We can discuss both papers, noise and general.
Right. Then because this is the first time, let's start with the noise paper then.
Yes, noise paper. Now this is 2017-18 basic electricity, radio and electronic theory. Question number 1. The unit of electric charge is there are 4 answers: volt per meter, coulomb per square meter. Answer is coulomb. That means third answer. Answer is third one, coulomb. And other answers, volt is the unit of potential difference or voltage, that is the volt. And volt per meter is the unit for the electromagnetic field. Field strength unit is volt per meter. And fourth one, coulomb per square meter. That is charge density. If there are some electric charge distributed surface, then you can use coulomb per square meter. The answer for this one is number 3. Answer number 3. Then question number 2. The conductance of a wire is directly proportional to the surface area of conductor, the resistivity of the material, the length of the conductor, the area of cross section of the conductor. Now here question is conductance of a wire. Conductance of a wire directly proportional to the cross section of the conductor. Here which answer? Surface area, resistivity, length of conductor, the area of cross section. Number 4 is the answer. 4 is the answer. And we can explain another thing with resistivity. Resistivity is directly proportional, inversely proportional to this area of the cross section. That is resistivity. But here the question is conductance or conductivity. Conductivity is directly proportional to the area of the cross section. Then number 3, there is a small diagram here. The effective resistance between A and B. I'll draw the diagram first. Now you can see this one and these four resistors. Now there are four resistors here. All are connected. Actually, all are short circuited. Connected both terminals connected together. That means these four resistors, 1, 2, 3, 4. These resistors are short circuited. Then you can simplify this circuit. Now this is equal. This one R, and again this one. These four resistors are short circuit. That means resistance is 0. Then you can omit all that, only these two. Then equivalent resistance is 2R. 2R. ඒක ප්‍රශ්නයක් නැතුව ඇති නේද? පළවෙනි එක උත්තරේ. First one is answer 2R. If any question, you can ask. Huh? Then question number 4, 20 dB power gain is increased by 2 times, 10 times, 20 times, or 100 times. 20 dB power gain. For the power gain, you have to use this equation. 10 log P2 upon P1. This is power gain. For voltage gain, you have to use 20 instead of this 10. For power gain, this is the equation. Power ratio here, and this is the power gain. Then answer is 20 dB. 20 dB power gain. 20 equals 10 log something. Then if you divide 10, both sides divide by 10, then you can see 2 is equal to log something. Now you must know the meaning of logarithm. Logarithm normally 10 equal 10 to the power 1. 100 equal 10 to the power 2. Now here log 100 is equal to 2. Log 10 is equal to 1. That way 2 is equal to log 100, yes. Logarithm of 100 is 2. Now here 2 is equal to logarithm of 100. Here you can use 100. That means the power ratio is 100. ඒක කාටවත් ප්‍රශ්නයක් එහෙම තියෙනවද? Then the answer is 4. 4 is the answer. Any questions? ඊළඟ එකට යන්නද මම number 5. What is the energy stored in a 2 Henry conductor carrying current of 2 ampere? For the energy stored, there is an equation. Now you must remember energy stored in capacitor and inductor. For capacitors, the equation is half CV squared. Inductors, හරියට මතක නෑ පොඩ්ඩක් කිව්වා RS one moment. පාටාදි මතකද equation එක half Li squared වගේ අන්න එහෙම එකක් මට මතක.
වරුණ කලින් ලියාගත්තේ ඒවා තියෙයිද?
සර් කලින් කිව්ව ඉක්වේෂන් එක නේද?
half Li squared එක half Li squared මේක තමයි මේ energy එක. Capacitor එකක නම් this one for capacitor half CV squared. For inductor half Li squared. Then what is the question? What is the energy stored in 2 Henry capacitor? That means L is equal to 2 Henry. Inductor carrying current 2 ampere. That means I is equal 2 ampere. Then this is equal to half L I 2 squared. That means 4. Answer is 4. The unit is joule. Joule. 4 joule. Because this is energy. The unit of the energy is joule. හරිද ඒක ප්‍රශ්නයක් මොකද තියනවද? Then number 6, the total capacitance between A and B in the circuit shown below. Circuit එක අඳින්නම් මෙතන. You can consider these two parallel capacitors. Now these two are in parallel. Parallel two capacitors is equivalent to the addition of these two. That means C plus C. Then this one is equal to 2C. Then this one and other 2C, that is in series. If you connect two capacitors in parallel, we have to add those two. Now here, two capacitors in series, this one and this one. Then the equivalent capacitance is half of this one. That means C. Answer is C. Number 1. Next question, number 7. The peak value of 240 volt, 50 hertz. Peak value of 240 volt 50 hertz main supply is. Now I'll draw this waveform. If you draw this waveform, 240 volt is not the peak value. Actually, it is somewhere here, another value somewhere here, not the peak value. This one is 240. Then question is, what is the peak value? Relationship between the peak value and this is called RMS value. RMS is equal 240 volt. RMS mean root mean square value. RMS value is 240. Then peak value is 240 multiplied by root 2. Root 2 multiplied by 240. Root 2 is 1.41 root 2. Then multiply this one with 1.41. Here answer, you can give the answer this way. Root 2 into 240, that is the peak value. Peak 240. This is the answer. That means number 3. Now, if I ask what is the peak to peak value mean from here to here. Here one peak, here another peak. Peak to peak is this one. That means twice of this one. Here answer is number 3. Any questions?
So mean value එක පොඩ්ඩක් ඒ ගැන පොඩ්ඩක් ඉස්සර කරන්න mean
මොකද?
mean value.
Mean value.
Oh.
Mean value is actually mean value or average value. Average. Now, if there are some, I think you can remember for small classes we use to find this average or mean value. If there are some students, say 4 students, their age we can take 12 years, 11 years, and 13 years, 15. If I ask them what is the average value of these 4, then you have to add this total everything and divide by 4. That is the average value. Now, for this one, you can apply this way. If we can take these values, V1, this is V1, V2, V3, V4, V5. V1, V2. You can add these 5 values and divide by 5. That is the average value. But this is average value for 1/2 of the cycle. 1/2. Then for total cycle, we have to add another these values also. Then this one is positive, this one is negative. When you add, it will be 0. That means average value of 240 volt is equal to 0. That is the average value. But here RMS means root mean square. Now you can get this way. Root mean square mean first we have to square these all value. Square of this. And mean value of square. Mean value of square is add these figures and divide by the number of figures. Now here 5 voltages, then square and add, then you have to divide by 5. That is mean square. Then you have to take the square root of this one. That is the root mean square. When you add square of these figures, plus and minus, both are no difference. Minus also, -1 minus value multiplied by the same value, that means positive value. That means the total of these figures, this one and this one, squared, that means not 0, there is some value. And you can divide by that number, that is the root, that is the mean square. Then you can take the square root value. ඒක තමයි RMS. ප්‍රශ්නයක් තියෙනවද ඒකේ?
Sir, in our main domestic line, 230 is there.
Yes.
I want to whether it's RMS value or peak value.
That is RMS value.
That is RMS value.
230, normally we use 230 volt or 240 volt. That is RMS value. RMS value is this way calculate the value. It is not the average value or mean value. හරිද එතකොට ප්‍රශ්නයක් නැද්ද දැන්? Shall I go to next one? Number 8. The total inductance between P and Q in the circuit shown below. Total inductance between P and Q. Yeah, actually, these two are short circuited. If you use this line, that means this one and this one short circuited. Then you can simplify this way. Only this one and this one. Resistors also same. Now these inductors. For inductors also same way. L plus L. That means 2L. 2L. That is answer number 1. That is the answer. And another thing, if this is not short circuited, then you have to get these two first. That is parallel. Parallel means 2L and 2L parallel. That means average equivalent value is L. If it is not short circuited, the equivalent value of this one is L. Now here these 2 points short circuited, then only two. You have to consider only these two. Ken, any question? Can you understand? ප්‍රශ්නයක් තියෙනවද කාටවත්? Shall I go to the next one, number 9? Number 9, a transformer is laminated to reduce eddy current loss, reduce hysteresis loss, increase exciting current, increase magnetic flux. Transformer is laminated. Normally transformer laminated to reduce eddy current loss. Question number, answer is number 1, first answer. Reduce eddy current loss. transformer, any idea about transformer? Shall I show a transformer? Now I have here a small transformer. Actually, I dismantled this one. Now this is the transformer core. This core of transformer, this one, and there are some two coils, sometimes more than two. The coils are turned this way, and this core, actually I removed one part. Then you can see this one and the middle part and this one. That is altogether some laminations, small steel plates are connected here, inserted. If any current passing through this coil, that lamination becomes if any current passing through this coil, this lamination steel, normally this is soft iron, not steel, soft iron converted to a electromagnet, magnet one side. If the current is going this way, this magnetism is one side, and if the current reverse, the magnetism will be reverse. මේ යන කරන්ට් එක පැත්ත මාරු වෙනකොට මේකේ තියෙන මැග්නටිසම් එකක් පැත්ත මාරු වෙනවා. When it is change the direction of this magnetic system, magnetic property, actually magnetic particle, there are some magnetic particles here. If it is one side, if the current change to other side, these particles turns to the other side. මේකේ තියෙන molecules ඔක්කොම මාරු වෙනවා, කරකැවෙනවා. එහෙම වෙනකොට වැඩි current, වැඩි energy එකක් ඒකට යනවා. If these molecules are turned to the other side, then there are some energy for these turns of the molecules. That energy is a power loss. That is we call eddy current loss. Then that loss you can reduce by using this laminate. Make a local solid එකක් නම් ගොඩක් current එකක් මේ loss වෙනවා. ඒ තහඩු වලින් හැදුවාම ඒ loss එක අඩු වෙනවා. Eddy current loss reduced by using this lamination. If it is solid iron, that eddy current loss is increased. It is more loss.
I want to know, sir, eddy current loss may be dissipated as a heat. Am I correct?
Say again, please.
ඒ කියන්නේ එඩි කරන් ලොස් එක හින්දාද හීට් එක නගින්නේ මේ
Heat එක ඔව්.
ඔව්
ඔව් heat එක වැඩි වෙන්නේ ඒකයි. ඒක නිසා රත් වෙනවා. eddy current loss නෙමෙයි. eddy current එක නිසා රත් වෙනවා. It is heating due to eddy current. That means that heat is a loss. තේරෙනවද? eddy current එකකින් ද රත් වෙනවා. එතකොට ඒ heat එක මේ හානියක් නෙ වෙන්නේ. තාප හානියක්. ඒකට කියන්නේ eddy current loss. හරිද ඒක? ප්‍රශ්නයක් නැද්ද? Transformer is laminated to reduce eddy current loss.
හරි සර් හරි
And the second answer, reduce hysteresis loss. Hysteresis loss means now when the current is going this way, if the current is passing one side, all molecules are turned to one side. When the current reverse, that all molecules are turning to other side. For that turning, there is a loss. That is the hysteresis loss. ඔය දෙකේ ටිකක් රිලේෂන්ෂිප් එකක් වගේම පොඩි වෙනසක් තියෙනවා. Eddy current and hysteresis are not same. They are interconnected. Those two are interconnected, but not same thing. Eddy current loss is due to that current, some power loss. Hysteresis loss is due to the current, molecules are turning to the other side. ඒ molecules turn වෙනකොට ඒකෙන් loss එකක් එනවා. ඒක hysteresis loss කියනවා. When the molecules turning to the other side, there is a loss of energy. That is the hysteresis loss. Then shall I go to the other question, number 10? Product detector is used for the detection of AM signal, FM signal, SSB and CW, PM signal. Product detector is some electronic circuit used for demodulate SSB and CW signal. Demodulate means detection of SSB and CW signal. That is product detector. For AM signal, demodulation of AM signals, we can use diode and capacitor. Diode and capacitor, that is only a simple circuit. The product detector is not such simple. Anyway, it is used for demodulate or detection of SSB and CW signal. Then answer is number 3. SSB and number 3 is the answer. For FM signals, you can use another one. that is we call FM discrimination, I think. FM discriminator circuit. For SSPCW, we can use another one, BFO, beat frequency oscillator. That is another system. BFO. BFO means another signal, another RF signal mixed with the radio signal. Now, if you consider radio receiver, you can input some radio signal. That radio signal convert to audio signal. That is normal radio. For SSB and CW signals, actually this SSB or CW RF signal straightly going to the speaker, but you can't hear anything because that is RF radio frequency signal. If you mix another radio frequency signal, now for example, if you use 7000 kilohertz, that is the signal coming from the antenna, and another BFO unit. BFO unit means another oscillator. That oscillator produce another signal. You can will assume that 7001 kilohertz. Then the difference between this one and this one is 1 kilohertz. 1 kilohertz means 1000 hertz. That signal, audible signal. You can hear this signal, but this one and this one you can't hear. We can hear only normally between 20 hertz to 20 kilohertz. This is the normal hearing frequency range. That 1 kilohertz is in between these two range. Then for this way, if you demodulate or detect with this way, it is called BFO, beat frequency oscillator. And this question, there is another unit, product detector. That is also same thing. Any question for this one? Question number 11. The reactance of 20 Henry smoothing choke at a frequency 50 Hz is now here reactance of a smoothing choke. That means there is another smoothing choke this way, coil. This is some kind of a choke. If the inductance is L and the frequency of this signal, some signal is passing through this one, the frequency is F and inductance L. Then reactance XOXL is equal to 2 pi FL. This formula is very important. You must remember this formula. reactance of 20 Henry smoothing chalk at a frequency 50 Hz. That means 2 pi into 50 into reactance 20 Henry. Then 20. 20 Henry, 50 Hz. Now this is the value of inductive reactance. Then you multiply this one. Here 5 into 2, 10. That means 1000. 2000 pi. 2000 pi. Or you can write 2 pi kilo ohm. Now this one is ohm. 2 pi kilo ohm. That means answer is number 3. हर जे के प्रश्न ने කෙලින්ම ෆෝමියුලා එක use කරනවා. Direct apply this formula. For constant voltage, a capacitor will act as constant voltage. Now, if you connect the capacitor to a battery, say 6 volt here, you can connect this battery directly to the capacitor. Then what happened? Initially, within a few milliseconds, some charge is going into this capacitor, and after that it is discharged capacitor. If you disconnect this one, the charges remain same. For constant voltage, capacitor will act an open circuit. If you connect this one, it is capacitor is charged, but it is after that it is not like a disconnect. This is make a දාලා නෑ වගේ කනෙක්ට් කරපු හැටියෙම charge වෙනවා ඊට පස්සේ මේක අයින් කළත් මුකුත් වෙන්නේ නැහැ. එතකොට එහෙමනම් ඒක open circuit එකක්. ඒ කියන්නේ current එක දිගටම යන්නේ නැහැ. Current is not flow through the capacitor. Initially some current going through to the capacitor and charge. After that current is not passing. Current is not passing mean open circuit. The answer is number 2. Number 2, open circuit. When the antenna length, number 13, question number 13, when the antenna length is doubled, the resonant frequency, resonant frequency becomes half. That means you can use this formula. C is equal to V F lambda. Not C, this is, you can use V, letter V. This is actually, this is the speed of light or speed of electromagnetic wave. That speed is equal to F into lambda, F lambda. If you use F in megahertz and lambda is meters, then megahertz into meter is equal to 300. You can remember this one. Always 300 is the answer of the multiplication of these two, frequency and wavelength. Then here when the antenna length is doubled, antenna length, that means number of meters. Normally antenna half wave dipole antenna is the length of this half wave dipole is half wavelength. Wavelength by half of the wavelength. And then it is increased. The frequency should be reduced. Antenna length is doubled, the resonant frequency becomes half. Then answer is number 1. මේ දෙකේ ගුණිතය නියතාවයක් වෙනස් වෙන්නේ නැහැ. එතකොට මේක දෙගුණයක් කළොත් මේක භාගයක් වෙනවා. අන්න ඒකයි. Number 14, on a transmission line, voltage standing wave ratio is given by that is number 3, V minimum divided by V maximum. On a transmission line, if you consider this transmission line, the voltage and current, if you can measure the voltage and current here, and another point, if you measure the voltage and current another point, it is different. Actually, measure කරන්න බැහැ. නමුත් theoretically you can take voltage and current, here some value, here another value, here another value. That means there are some minimum voltage and maximum voltage. Then standing wave ratio, SWR equal V minimum divided by V maximum. Always SWR is between infinity and 1. Minimum value is 1, maximum value is infinity for the SWR. If the antenna is perfectly matched, SWR is equal to 1. You must remember that. Then question number 15, there is a resistor. Resistor with 4 color bands: red, green, brown, gold. Actually, this fourth one is the tolerance. Fourth one is tolerance. These 3 values you can use the number of that resistance, number of ohms. Red, green, brown. Red is 2, red 2, green is 5, 2, 5, brown is 1. 1 means only 1, 0. That means 250 ohms. If the third one is 5, that means 5 zeros. 5 zeros mean 2.5 million. That means mega ohms. Here 250 ohms. Number 2 is the answer. Then question number 16. In the following diagrams, which represent the diode in forward biased condition? If a diode connected with forward bias condition, that means current flow this way. If the current flow this way, this type voltage is more than this side. අන්න ඒක මතක තියාගන්න. voltage එක මේ පැත්තේ වැඩි වෙන්න ඕනේ, මේ පැත්තේ අඩු වෙන්න ඕනේ. එහෙම වුණොත් තමයි current එක කියන්නේ. Now here 4 answers. Number 1, 5.6 volt and 5 volt. That is correct. If this is this side 5.6 and this side 5 volt, that means it is forward bias. Number 2, here 5 volt, here also 5 volt. That is actually not a forward bias or reverse. And number 3, here 12 volts, here 15. It is actually reverse bias. If it is reverse bias, this side voltage is more than this side. Number 4, both are zeros. That means no current flow. Then the answer is first one. Now first one, here 5.6, here 5 volt. Then what is the difference? 0.6 volt. 0.6 volt. Normally, there are 2 types of diodes, silicon diodes and germanium diodes. If you use silicon diode, the voltage difference should be 7 volt, 0.7 volt. Silicon diode. Germanium diode, that difference is 0.3 volt. මං කියන එක ඇහෙනවද? මොකද්ද මෙතන මෙසේජ් එකක් ආවා. Stop sharing කියලා. ඇහෙනවනේ ස්ක්‍රීන් එකක් පේනවනේ ඔක්කොටම.
Vijay,
ඔව්.
continue කරන්න.
හා
Go ahead.
ප්‍රශ්නයක් නෑනේ. හා.
Okay.
මේ සිලිකන් ඩයෝඩ්ස් වල 0.7 volt difference එකක් තියෙනවා. Here difference is that mean if you use 12 volt and I think some load here connected to 12 volt. We can consider this way. You consider this is a transmitter or some equipment use 12 volt with silicon diode. Then here voltage difference is not 12. It is 11.3. Here 11.3. That means 12 minus 0.7. That is the voltage here. If you use germanium diode here, this is 12 minus 0.3. That means 11.7. You can use these diodes for reduce the voltage without power loss. Now I'll give another example. If you have 12 volt supply and reduce to 10 volts, that means the voltage loss is voltage difference is 2 volts. Then for this one you can use a resistor. If you use a resistor 12 volt this way, this is some equipment, and use a resistor for reduce this voltage, then there is a loss of power. Now 2 volts reduced by the resistor, then power loss is I squared R. But if you use a diode for this one, there is no power loss. For silicon diode only 0.7 reduced. That means if you use 2 diodes this way, 0.7 and 0.7, that means 1.4 volt reduced, but it is not a power loss, only reduce the voltage. ඔය විදිහට ඩයෝඩ්ස් කීපයක් දාලා අපිට වෝල්ටේජ් එක ඩ්‍රොප් කරගන්න පුළුවන්. Number 17, copper and aluminum are the most widely used to make diodes, conductors, transistors, insulators. Copper and aluminum are good conductors. That means you can use for make of conductors. Normally conductors using with aluminum or copper. Copper is the best conductor. Aluminum is little bit low conductivity. Actually, the best conductor is silver. Best one, silver. Next, copper. Next, aluminum. You can compare the resistivity of these metals. For the resistivity, normally we use a letter rho for resistivity. Resistivity for silver is 0.94, that is silver, and copper is 1. Copper 1. Aluminium 1.6. This is the relative resistivity. And another thing, not relative, that is normal resistivity, that is another unit. You can refer this lesson 1.5.3. 1.5.3. You can, then you take my lessons. I think Ken, if you need read these lessons in my website, you can. www.qsl.net diagonal 4S7 VJ. Now you can take a link. The link is ham radio course. And after that, there are some links with English lessons. Actually, it is, I think, not English, only lessons. That means it is in English. And the next, if you go down, you can see another singular lesson. Then for Ken, you can read these English lessons, chapter 1, chapter 2, chapter 3. There are 8 chapters. For this chapter 1, you can see this conductivity or resistivity.
Okay. Thank you.
Okay. Number 18, what value of a resistor is required to drop 150 volt when the current flow through it 25 milliampere? What value of a resistor? What value of a resistor is required to drop 150 volts? Now here voltage drop 150 volt when the current flow through is 25 milliampere. Current is 25 milliampere. Then you have to find the value of R. Voltage is 150. You can use this V is equal to IR. Very simple equation. V is 150. I 25 milliampere. You must consider the unit. It is very, very important. If you use V is volt, I is ampere, and R is ohms, then if you use I in milliampere, you have to convert to ampere. 25 milliampere divided by 1000. This is number of amperes and into R. That means R is equal to 150 into 1000 divided by 25. And 25 into 6 here, that means 6,000. Or 6 kilo ohm is the answer. 6 kilo ohms. Number 4, no. Number 1, 6 kilo ohm. Number 1 is answer. Can you understand any question for this one? Then number 19, a bipolar junction transistor has junction transistor actually 3 layers. No? Transistor has three layers. One, this is called base, and this is collector, and this is emitter. There are small metal beads, 2 beads connected to another metal. That means 3 metals. That means 3 layers. 3 layers. Number 3 is correct. Number 20, a PN junction allows current flow when it is PN junction reverse bias away from P and N type semiconductors, forward bias induced by a magnet. PN junction allows current flow when it is forward bias. Actually, it is not only for PN junction or in NP junction, any junction, current flow, if it is with forward bias only, current flow. It is not current. No, current is not flow with reverse bias. And question is, answer is number 3, forward bias. Number 3. ඒක තේරෙනවනේ මේ PN junction වුණත් NP junction වුණත් current එකක් කියන්නේ forward bias නම් විතරයි. Then question number 21. Now this is the full wave rectifier. Full wave rectifier. Then current. And now here actually some wave is going this way. The direction is changing, alternating current. Then current flow, if it is, you consider the first part, this one, then current flow this way. This way, and here this way, again here this way, and going through Y. Current entered X and it is going this way. Wave theater. Then next moment, the other half, this one is comes and rectify this one. Next moment, current is going this way, and here this way, again same side, and going this way. With it, and for this moment, current flow this way. The other moment, current going this way. Always the current, output current is same side. That means here, output current this way. Then answers, first answer is actually for half wave rectifier. And third one is the full wave rectifier. For this type, answer is the third one. Number one is full half wave rectifier. Then answer is number 3. Any question for this one? මේක 2.4යි මේ ඒක කිසි ගන්න දෙයක් නැහැ, මේකට සම්බන්ධයක් නැහැ. AC wave එකක් තියෙන්නේ. Number 2 and number 4 for AC output. Here actually output is DC, not AC. Number 22, there is a transformer. Input is 230 volt AC with 50 Hz. Output is a DC output. That means it is connected diode. One diode is connected to the output. I'll draw the diagram. AB terminals are fed with 230 volt AC 50 Hz voltage. That means here input voltage 230 and frequency is 50 Hz. D is a diode. This is a diode. And C is a capacitor. C is a capacitor suitable for this circuit. Suitable means actually this circuit we use for AC convert to DC and getting smooth DC current. This capacitor called smoothing capacitor. Suitable capacitor means that this is the smoothing capacitor. Smoothing capacitor normally we use for smoothing capacitors about 100 to several thousand microfarads. What should be the current waveform between L and M? Actually, this is the power supply used for this load. This resistor is a load. You can consider it like a radio or some other equipment. For this one, you have to use smooth DC voltage. If you use this diode, that means current this AC current convert to DC. Only one side, only one diode. That means this moment current is flowing and the other moment no current. If you use two waves, it is this way. Now this part is disappeared. Only this one and this one. Actually, this is the output current for this one. Without this, without capacitor or load, output current is this way. But if you use a smoothing capacitor, it will be convert this way. Not this way. If it is very good smoothing capacitor, the current is like this way. Here the fourth answer is correct. Fourth answer. First one is only for this diode. Without this one, first one. Second one, not used for this one. It is for full wave rectifier. The second one. Third one is if there is no rectification. That is the third one. And fourth one, rectification and smoothing circuit, both together. Then the current is this way actually this way. Like normal this waveform, but always the positive side. Then the answer is number 4. Number 23, a rectifier diode is used in direct current circuits to 1. Prevent the damages by supplying power from positive and negative terminals which are incorrectly connected. A rectifier diode is used in direct current circuit. Now you can consider a power supply unit. Power supply unit. Here apply AC current. Here power output is DC, plus and minus. A rectifier diode is used in direct current circuit. That means you can use a rectifier for this side. This is the direct current side. If you use this way to a load, you can consider transmitter, or you can use TRX, transceiver, or any other electronic equipment. If you use this type 1 diode, number 1 is prevent the damage by supplying power from positive and negative terminals which are incorrectly connected. That means if positive and negative terminals connect to incorrectly, වැරදි විදිහට කනෙක්ට් කරොත් එතකොට මේක ඩැමේජ් වෙනවා. If you connect now this transceiver, this is positive, this is negative. If you connect positive to this one and negative to this one, this will be damaged. Transmitter එක නැත්නම් මේ උපකරණය ඩැමේජ් වෙනවා මේ දෙක මාරු වුණොත්. ඒතකොට ඒක වළක්වන්න පුළුවන් මේකෙන්. You can prevent the damage of the reverse of this supply terminals. You can use this rectifier for this one. If you use this rectifier, always it is going to this way. Number 2, prevent damages by supplying power to a source with high voltage. With using this diode, there is no prevent damage by supplying the high voltage. ඒකට මේක අදාළ වෙන්නේ නැහැ. ඒකට වෙනම circuit එකක් දාන්න වෙනවා. You can use another special circuit for prevent the damages supplying with high voltage. Number 3, prevent the damage by supplying alternate current. Alternate current එකක් ආවොත් මේකෙන් ඒක මේ diode එකෙන් ඒක ගන්න පුළුවන්. Alternate current is not passing through the diode. Through the diode only passing one direction. That means DC current. Now that is also correct. Number 4, prevent the damages due to lightning. It is not here. Due to lightning, you can't use this diode and reduce the damages due to lightning. Now here, this is useful for the first one, prevent damages by supplying power from positive and negative terminals which are incorrectly connected. Now these two incorrectly, if you connect incorrectly, then nothing happened due to this one. If if you use incorrectly, if you connect the incorrectly without this diode, this will be damaged. Then number one is the correct answer. And three also correct, prevent the damages by supplying alternating current. දැන් මේ පැත්තේ alternating current එකක් නම් එන්නේ මේක දැම්මොත් ඒකත් මේ ඒකනොත් ආරක්ෂාවක් සැපේනවා. If you connect alternating current this side and with the diode, it is not going, passing only the DC current. That is also correct. But here more correct is answer number one. Prevent the damages by supplying power from positive and negative terminals which are incorrectly connected. Actually, this is very useful. If you made some circuit, say a oscillator, Morse oscillator, like that, if you use that circuit, always you have to use the correct power supply terminals, positive and negative terminals. You have to connect without always connect to the correct way, positive to positive, negative to negative. But sometimes by mistake you can connect the other side. We can use the diode for prevent this one. දැන් මම මොකක් හරි සර්කිට් එකක් හැදුවොත් මොකක් හරි අපි හිතමු PCB එකක් හදලා මේකට දානවා ඩයෝඩ් එකක් ඔය වගේ. මේක තමයි ඔහොම දාන්නේ. මේව දැම්මහම මට වැරදිලා ඔක අනිත් පැත්තට කනෙක්ට් වුණොත් ප්‍රශ්නයක් වෙන්නේ නැහැ. If you made some circuit, always you have to use a diode for prevent that incorrect supply and that incorrect thing you can correct with using this diode. Otherwise, by mistake, you can connect the other side, the circuit will be damaged. Then question number 24. Now this is the circuit. All the diodes are in above circuit is 1.8 volt LEDs. Which LEDs are light up when a 6 volt battery supply. Now here 6 volt battery is connected to the terminals X and Y. This is X, this is Y. Actually, this is very simple. Now this is the positive terminal. Then you can consider this way. Current is flow this way, and from here current going this way, not this one. And then pass this way, and here current pass this way, not through this one, and going this way. Then again current pass in this way and to here. Then D5 is lighting. Now this one is not lighting because the current is not going this way. Current passing this way, then D5 is lighting. Then it is not going this side, it is going to this way. D2 is lighting. D5, D2, and here D6. Only these three are lighting. D5, D2, D6. D5 to 6. That means answer number 2. Make any any question about this one? Number 25, PO silicon is a insulator, conductor, semiconductor, inductor. I think it is semiconductor. Pure silicon මම හිතන්නේ semiconductor මේක insulator ද කියන්නත් බෑ ටිකක් හොයලා බලන්න. Pure silicon, I think it is a semiconductor. Normally pure silicon is used for make semiconductors, but pure silicon I have a doubt whether it is semiconductor or insulator. Anyway, you find out that with some documents. පොඩ්ඩක් හොයලා බලන්න. මම හිතන්න semiconductor කියලායි. නමුත් insulator properties තියෙනවා මේ pure silicon වල. I have a doubt 1 or 3 is the answer. Number 26, to troubleshoot an electronic instrument. It is advisable to read user and service manual first. Yes, that is the correct answer. Any electronic equipment, if you use uh, a troubleshooting, that means you have to use service manual. User manual and service manual both you have to use. Number 2, it is advisable to use a multimeter. This is not correct. Number 3, advisable to use a voltmeter. Number 4, advisable to observe by opening metal box first. First one is the answer. Read the user and service manual. Actually, for troubleshoot mean repairing or servicing. That mean you better use service manual. But normally, when you use an electronic instrument, you have to use the user manual first. Here, number 1 is the answer. Number 27, Zener diodes are used in power supplies, modulator, demodulator, low pass filter. Power supply. Zener diode is actually this is controlling the voltage. It is normally used voltage as a voltage prevent the voltage variation. That means
ඒ කියන්නේ breakdown ද?
no, breakdown. Constant voltage එකක් ගන්න එක.
breakdown voltage එකක් නේද ඒකද?
Voltage stabilizer. Zener diode is used for voltage stabilizer. එහෙම නැත්නම් තව වචනයක් තියෙනවා නේද ඔකට? Voltage මට ඒ වචනේ එකපාරට එන්නේ නැහැ කටට. Zener diode එකෙන් කෙරෙන දේ දන්නවනේ. Now this is the symbol of a Zener diode. Zener diodes normally you can use if a variable voltage is varying, positive, negative. This is not constant, variable voltage. If you use a Zener diode circuit, the output should be constant voltage without varying. Answer is Zener diode is used in power supplies. Power supplies කියන එක තමයි උතන හරි. අනිත් ඒවා ඔක්කොම වැරදි. In power supplies. But the purpose of the Zener diode is get a constant voltage. If it is variable voltage, now for example, VF4 circuit of a transceiver. Now here you have to use some DC current and get a constant frequency. For constant frequency, the output frequency will be constant if the input voltage is constant. For getting the constant voltage, you have to use diode. Diode, there is another system, voltage voltage regulator diodes. It is voltage regulator. Voltage regulator. There are some ICs for voltage regulators. That is 7805, 7812, like that, 7810. These ICs you can use as voltage regulator. That means input, for example, this IC. This IC input output method, in out. This is minus. If you use input voltage, now if you consider this voltage is varying from 6 to 12 volts, it is variable. If you use 7805, always it is output is 5 volts for this one. 78, if you use this IC, you can get the output constant 5 volt output. The input voltage is varying 6 to 12. If you want to 10 volts, you can use this IC. For 12 volts, this one. ඒකේ මොකද ප්‍රශ්නයක් තියෙනවද ඔයගලන්ට? Without using this IC, you can use a Zener diode and separate circuit, but you have to calculate the values. Normally, Zener diode is using this way. This is positive, this is negative, and Zener diode is using this way. And here, resistor. Now this is the output voltage. You can use some electronic equipment with a constant voltage. Now there are some value for Zener diode about, for example, 6.8 volt or 9.2 volt, like that. If you use this Zener diode and a suitable resistor, always this side is 6.8 volt. Now this is this should be variable about I think about 10 to 20 volt variable supply. Then here only you can get 6.8 constant voltage. ඒක පැහැදිලිද මේකේ මේ පැත්තේ වෙනස් වෙනවා නම් මෙතන constant වෙනවා වෙනස් වෙන්නේ නැතුව. ඒකම මේ IC එකනොත් කරනවා. Then number 27, answer number 1. Then question number 28, the lowest layer in the ionosphere is D layer. Answer is fourth one, D layer. there are few layers around the earth. The lowest layer is D layer, then E layer and F layer. F layer is normally during daytime there are it is becomes two layers, F1 and F2, and others are only during daytimes. At night, D and E layers disappeared in the night time. Night time only these F1, F2 layers connected to one layer. Only one F layer is uh, acting during night time, and during daytime this F1 is divided into two, F1 and F2, and the other D and E layers also uh, acting during daytime. Then the answer is the lowest layer is D layer, fourth one. Huh? Generally, dummy loads are made by non-reactive resistors. Question answer number 2. Dummy load is normally you have to use a transmitter to an antenna. Then if you connect this way and generate a signal, that RF signal is going to the antenna and radiate. If you need to adjust your transmitter or test or repair, then if it is radiate with antenna, it is going to the other stations, other receivers. Then it is some difficult to this repair or this tuning or alignment. Then you are you better disconnect this antenna and connect to another dummy load. Dummy load that is actually a resistor, but it is non-reactive resistor, pure resistor. If it is pure resistor, no power loss, only all power is going to the resistor. Then you have to use without any inductive property. Normally, this non-reactive resistor is it is made out of some material without that mean there are some resistors with wire wound or carbon film resistor. Carbon film or wire wound resistor have some reactance. Now we have to use for dummy load without any reactance, pure resistor only you can you must use as the dummy load. Dummy load එකක pure resistor එකක් විතරයි පාවිච්චි වෙන්නේ. That main answer is number 2, non-reactive resistor. The frequency above 1 gigahertz, that is number 30. Question number 30. The frequency above 1 gigahertz is generally referred to as 1 gigahertz. That is microwave range. No? High frequency is wrong. Very high frequency wrong. Yeah, that is microwave. You must remember the frequency range for all wave bands. High frequency band is 3 megahertz to 30 megahertz. This is high frequency band. Very high frequency, that means VHF. VHF is 30 to 300 megahertz. That is VHF. UHF for ultra high frequency, UHF. That is 300 to 3000 or 3 gigahertz. 3000 megahertz to 3 gigahertz. This is UHF. Above 3 gigahertz is a microwave. Now here the frequency above 1 gigahertz. Actually from 300 megahertz to 3 gigahertz is UHF. But normally above 1 gigahertz we call as microwave. And the next range is HS, super high frequency. That is 3 to 30 gigahertz. This is also used as microwave.
So Vijay, today's lesson shall we wind up? No, right
Yes.
now.
Yes, I
Because
think it's better now. 10:50.
now we are discuss the number of question in here, and next time I will continue in this session. I think all of guys agree with me.
Yes, then we can continue next Thursday.
Thursday, yes, Thursday,
Yes.
8:30 sharp. 8:30 we start. Shall we
Yes.
start? I
Then
think that's
from
better.
this month,
That's better to know.
yes. The other part is we can do the other part on Thursday.
Thank you, Manoj.
Mm,
So, Vijay, let's wind up for today then. And our participants, if you can show, you can ask questions and you can talk during the session. Okay, so it will be easier for Vijay if he gets some feedback from you. So during the next session, if possible, please,
yeah,
when you have a question, please raise it,
yeah,
or at
yeah.
least
That's good. That's good. That's
confirm
right,
what you
Taranga.
need. Yeah. So thank you,
Okay,
Vijay.
then we'll meet on the next Thursday.
Thursday.
Okay,
Okay, we'll continue on Thursday.
right.
Then
Okay,
7
Kasam.
Good night. Good night, all of
Okay,
you.
okay, good night. Then thank you, Mr. Vijay. Okay, thank you everyone.
No, thank you, sir.
Vijay,
Good night.
when you go, when we sign out, so you said 73. What is the meaning of 73, Vijay? With that, we will wind up.
Yeah, 73 mean best regards. Sometimes some are calling best 73, but it is not good practice. Normally, there are some abbreviations for ham radio. There are some abbreviations. 73 is best regards. Best regards. Then don't say best 73 or something, only 73.
Right.
Okay, Manang.
Okay, so you learned something from the ham jargon. Hari Vijay,
Okay,
let's
then.
wind up then.
Good
Good
night.
night and 73 to you all.
Good night.
All right, good
Good
night.
night, good night. Thanks all.
Okay.